For question number 11, we want to use implicit differentiation to find the derivative. First thing we're going to do is begin by differentiating both sides of the equation with respect to x. So we're going to do d dx of y squared plus 3x to the fifth. It's going to be equal to d dx of 8. The derivative of y squared is going to be 2 times y, but then from the chain rule, because y is a function of x, we need to multiply by y prime plus the derivative of 3x to the fifth should give us 15x to the fourth. And this is going to be equal to the derivative with respect to x of a constant is just going to be 0. So we implicitly differentiated both sides of our equation, and we come up with this expression. The very next thing we need to do is solve it for y prime, because we want to find the derivative. The very first step would be to get the y prime by itself, is you would want to subtract a 15x to the fourth from both sides. This will give us 2y prime is equal to negative 15x to the fourth. And then we have one more step. In order to get the y prime by itself, you'd have to divide both sides by 2y. And we get that y prime is equal to negative 15x to the fourth divided by 2y. And this is a perfectly acceptable and valid form for the derivative, because again, if you go back to the original expression, this was an implicitly defined function of x. So y was defined implicitly in terms of x, meaning your equation had a mixture of x's and y's. It wasn't set up like y equals stuff with x. And similarly, when we find the derivative also is implicitly defined in terms of x's and y's. We don't just have y prime equals an expression for x, but this is your final answer.